So yesterday we talked about some scatter plots, and we graphed some lines using the what I call the pick-a-point method. And the pick-a-point method means you generate a table of values. You can, if you want, get the equation into y equals form, or some of you are getting it into x equals form, or you can leave it as is. But the goal is to generate a table of values. Sometimes the equations are going to look a little different. And so we're going to talk about those. And then we're also going to generate another method for graphing lines. So one special case is where you have to graph, for example, the line y equals 4. So it's called a special case because there's no x value. So when you graph it, it's just y equals a number, and there are no two variables. There's only one variable. So it looks weird. People generally have some difficulty graphing it because it doesn't follow normal rules. So it's y equals a constant value. So when you take a look at the table looks extra funny because this is what it actually means. It means y is always 4. Okay? That's what it means to graph y equals 4. It means the y value is always 4, and because x isn't mentioned in the line, x doesn't even come up in the line, x can be any number you want it to be. So you can pick any values here, like -2 to +2. And when you go ahead and graph those, we can take a look at what the line looks like. So we have -2, 4, -1, 4, 0, 4, 1, 4, and 2, 4. And if we connect the dots, we get a horizontal line. So if you have an equation that just has one variable, such in this case y equals a number or y equals a constant value, this is what the table means. It means y is always that number. And when you graph it, it's just a flat line that has a y value that is constant. Okay? And again, on this line, the y values are always 4. Like this is -5, 4. This is 3, 4. So if you see y equals 4, that means y is always 4. All right? So it's one of those things that's almost so easy it's hard because what do they mean y equals 4? And it means y equals 4 always, and x can equal any number at all. So x equals -5, -4, -3, -2, -1, 0, all the way to infinity and negative infinity. So when you get y equals a number, it's going to be a horizontal line. Any questions on that? And if we have x equals a number, like for example, x equals 2, a line where x value is always the same, the table looks like this. So when it says x equals a constant value is what you're going to see will have no variable with it. So again, this is an equation that only has one variable. And because it only has one variable, that's why I put it in the characteristic as being a special case. And so x equals 2, and that implies that x always is 2. And then since y isn't mentioned, y can be any number. So I can choose any values for y. I can choose like -3, -1, 0, 1, and 3. But I could really choose anything I wanted. I'm just picking numbers that happen to be on my graph. So if I graph these, 2, -3, 2, -1, 2, 0, 2, 1, and 2, 3, and I connect those, instead of getting a horizontal line, I get a vertical line. Okay? So that's how we graph a vertical line, is by by having an equation that's just y equals a number. And again, every single value on here, the x value is 2, and the y value is whatever we want it to be. Whatever I want. Okay. So again, it's very, x equals 2 means x is always 2 and y can be whatever it wants. Any questions on that? So that's how we graph horizontal lines and vertical lines. Another thing we can consider with lines is a special characteristic of lines is what's called their intercepts. And the definition of intercept is it's where the graph crosses the x or the y axis. So to intercept means to cross. Most lines will have both an x-intercept and a y-intercept. So if we take a look at this line, we have a line. We can see the y-axis on the line. Can someone give me the coordinates of the x-intercept? In other words, where it crosses the x-axis? Davian? Try again.
Oh, sorry.
Negative 1, 0. And then can someone give me the coordinates of the y-intercept? TJ? 0, 2. All right, nice job. Now, if you are on a y-intercept, what is the opposite variable equal to? So this is the y-intercept here, because you see we're intercepting the y-axis. If you're on the y-intercept, what is the opposite variable equal to? Yes? The opposite variable, meaning the y variable equals 2. So the x variable equals, in the ordered pair, y equals 2 and x equals 0. Yeah, I'm sorry, I was not being clear. So at the y-intercept, x equals 0. You guys see that? So if you're on the y-axis, x equals 0. If you're at the x-intercept, what is the other variable, the y variable, equal? Really? Yeah, the y variable equals 0. So if you are at an intercept, the opposite variable equals 0, because it means you haven't moved in the x direction at all. If you're at the y-intercept, it means go left or right, 0 in the x direction. If you're at the x-intercept, it means go up or down, 0. So therefore, your y value equals 0. So the x-intercept is where y equals 0, because if here we're at negative 1, 0, and the y-intercept is where x equals 0. That is a big idea, and one that a lot of people forget. So the x-intercept, y equals 0, and the y-intercept, x equals 0, because you're right on top of the axis. If I'm on top of the axis, my x value must be 0. And back here, if I'm on top of this axis, my y value has to be 0. So when you're asked to list the intercepts, I'll show this in my example here. We're going to graph this equation, and we learned how to graph equations last week and this week using a table. This is another method that we can use to graph it. We're going to graph them using the x and y intercepts. So first off, we're going to find the x and y intercepts. So the directions say graph the equation using the x and y intercepts. So first thing, we're going to find the x and y intercepts. So to find the x-intercept, we're going to let y equal 0 and solve. So here's our equation. I'm going to plug in 0 for y. And this is the great part about finding the intercepts. When you find the intercepts, you get to plug in 0 for the opposite variable. 0 is great because 0 makes things go away, making the equation simpler. So if the equation is simpler, then it's a lot easier to solve. So then you have the equation 2x equals 6. So then we have 2x equals 6, and then you divide both sides by 2, and then x is going to equal 3. So when x equals 3, y equals 0. So the x-intercept is 3, 0. X-intercept is 3, 0. Any questions on that? Now for the y-intercept, we're going to let x equal 0 and solve. And our equation is up here. Sorry, I'm going to rewrite that. 2x, but I'm going to set x equals 0, so 2x minus 3y equals 6. So again, the beauty of using 0 is that it makes the equation simpler. So 2 times 0 is 0, so that goes away. So then we have the equation negative 3y equals 6. And we can just divide both sides by negative 3. And then y is negative 2. Y is negative 2, and then I can write my coordinates, my y-intercept, and I'm going to write the ordered pair 0, comma, negative 2. How many points determine a line? 2. Yeah, 3 is good for checking, but really you only need 2 to do it. So let's grab a graph. Here's my graph. So I'm going to graph 3, 0. 3, 0 is my x-intercept. So here's 3, 0, 1, 2, 3, 0. Then I'm going to graph my y-intercept. My y-intercept is 0, negative 2. 0, negative 2. Right there. Okay. And now I can draw my line equation. I can connect the dots. Now, one thing you can do to make your line straight is you can grab a ruler. Another thing I can do is I can consider that I have to go up to 1, 2, and over 3 to get to this point. So I can go up 2, over 3 to get to this point, down 2, over 3 to kind of give me some more points to connect. Like that. So I have my x-intercept and my y-intercept. What could be another way, or what could be a way to check my work? So I know I have the correct equation. Yes?
You could plug in whatever x or y equals.
So describe to me that process.
So like what would you for to figure out like if x and y equals 6, you could plug in 2 times 3 because x equals greater than 3 times negative 2 because y equals negative 2.
Okay, so you plug them back in to make sure you got your equations right. Okay. How about like something you used yesterday, the graph? You could use your calculator. So we're going to talk about that. Because that's a good idea.
Mhm.
What were you thinking? The table. So if you were to use a table, we already really have 2 points of the table. 1 point is right here, 3, 0. 1 point is right here, 0, -2. One thing we could do is pick another point and see if it's actually on this line. Because if it is, we're in pretty good shape. So does someone want to pick an x value that they like? Say again? -4. So if you pick x as -4, here I go. I'm going to plug in -4 for x. That's connected. A little crowded here. If x is -4, let's come down here. If x is -4, I'd say 2 times -4 minus 3y equals 6. So this is -8. So again, I do have to solve here. How did I get y by itself? Shirley?
Adding to both sides.
Good. -3y equals 14. What's next? Brennan? Good. And I would say normally keep this in the form of an improper fraction, but it's really tough to picture where that is on a graph. So I'm going to put this as a mixed number. How many times is 3 going to 14? So it's -4 2/3. So let's check that out on my graph. -4, -4 2/3. So let's scroll up a little bit. Let's see. And you can pick any number you want. So if I go to -4, 1, 2, 3, -4, -4 2/3. There you go, -1, -2. Here, let me grab a point so people at home can see this. -4, 1, 2, 3, 4, and then -4 2/3. 1, 2, 3, 4. I'd say pretty spot on. Do you guys see how this point works now? Okay. Now, Charlize, you mentioned the calculator. How would you plug that into your calculator?
So go to the graph and then you do.
Let's try it. Let's grab our calculators. What do we press?
Y equals. You sort of know why. So I think you said I don't know. So should we like x minus 3y equals 6? Or what would we put? Because
What do we have to do to enter this into our graphing calculator? What's that? What button do we press?
y equals.
So what form do we have to get this in?
Y equals.
Yeah, we have to get it in y equals form. So it says 2x minus 3y equals 6.
So we have this. So we have to add 3y to both sides.
Actually, I would keep the y where it is.
And then put 2y over there with 6. I mean 2x.
Yeah, so let's subtract 2x from both sides. Because the 2x is positive, so we have to subtract 2x on both sides.
So the 3y equals 6 minus 2x. And then
Okay, how about someone else? What would you do, Lisa? -3. Now you do have to divide all these by -3. Now watch this, you guys. This is y equals. Now generally we write the x term first, so I'm going to flip it. What's a negative divided by a negative?
positive.
So it's positive 2/3 x, and then this is minus 2. Because 6 divided by -3 is a 2, or you could write plus -2 as well. So Lisa?
We figure out if you put the fraction, so you have to put the variable. for the printer on the right, so. Doesn't matter.
It does not matter. So let's type y equals 2/3 x minus 2 in your calculator. So to type that in, it's just y equals is already typed, so it's 2 divided by 3, and then x, and then minus 2. And then you can press graph, and you can also look at your table, see if the table matches. So fractions are just the division button. And then second table.
Okay, no,
Now, I also, if you don't like looking at the graph, now, to look at the graph, you can look at the intercepts. Make sure it goes through at -2 and at 3. The intercepts are a great thing to check. Since you found them, they should match. The table's also a great thing to check. You guys feeling good about it? Should be y equals 2/3 x minus 2. So 2 divided by 3 x minus 2, like this. All right. So either way, you can grab another point, make sure that works. Okay, that could be a test situation since you won't have a graphing calculator during the test, or you could graph it. Okay. Here's your assignment. The goal is to finish it. So let's get going.